Vapor pressure. In this video, we're going to talk about vapor pressure and how it is affected by solutes. You should be able to calculate the vapor pressure of a solution for both a volatile and a non-volatile solute. We're only going to do the example for volatile solutes because it's the more complicated situation, but please make sure you practice with both. When you add a solute to a pure solvent, the vapor pressure is lower than that of a pure solvent. For a non-volatile solution, this is a relatively simple calculation, where the vapor pressure of the solution is simply the mole ratio of the solvent times by the vapor pressure of the pure solvent. And this is called Raoult's law. So thinking about what this means, as the amount of solute goes up, the mole ratio of the solvent goes down, and therefore the vapor pressure goes down too. This should make a degree of sense, since the more solute there is, the less solvent there is. If you mix two volatile solutions together, then the vapor pressures of both of them change. This is a combined version of Raoult's law. It is very, very similar though. The pressure of each component is the mole ratio of that component multiplied by the vapor pressure. Then, to find the total vapor pressure, you add those together. Now, of course, make sure before practicing any problems with this, you remember how to do mole ratios. If you don't remember that, you need to go back and practice that first before moving on to this material. Let's do an example with two volatile substances making a solution. I show you here that we have 25% by mass of benzene and 75% toluene. To get the vapor pressures, we'll need to use the vapor pressures of the pure solvents and then multiply by the mole fraction. To do that, we must get the mole fraction first. Since we don't have a sample size, we can pick any size that we want. The easiest, of course, when we get a choice, is to pick a 100-gram sample, which gives us 25 grams of benzene and 75 grams of toluene. From here, we can use the molar mass to convert each of these into their moles. Try this first before moving on to see the answer. From here, we get our 0.32 moles of benzene and our 0.8139 moles of toluene. When we want to get our mole ratio, we of course need to add this up in order to get our total moles, leaving us with 1.134 of our total moles. From here, we're able to find our mole ratios. We put the moles of each one over top of the total moles. So do this before moving on. For benzene, this is the 0.32 over the 1.134, which gives us a mole ratio of 0.2822. And for toluene, this is 0.8139 moles over the 1.134 moles, giving us a mole ratio of 0.7177. Now look at those two mole ratios and make sure that they add up to 1. They do, and so that's a really good indication that we've done our calculations correctly and that we haven't messed something up along the way. Now we can finish our problem solving. Finally, we take our mole ratio of benzene and multiply by the vapor pressure of the pure benzene. Similarly, taking our mole ratio of the toluene and multiplying that by the pure vapor pressure of toluene. This gives us 26.6 torr for benzene and 20.4 for toluene. When these are added together, we get a vapor pressure of 47.0 torr. We're able to do this in torr or any other pressure unit. You don't have to convert to atmospheres to be able to do this. Finally, we can go ahead and add this up to get our pressure total, giving us 47.0 torrs. In review, for a non-volatile solute, as more solute is added, the vapor pressure goes down according to the formula. For volatile solutes, you must calculate the partial pressures of each component and then add them together to find the final vapor pressure. You are responsible for being able to do both of these, even though we only did the more complicated version. So make sure you review the simpler version on your own.